What's up, scholars? Welcome back to Skill 39, Solving Complicated Trig Equation, Part 2. Well, first of all, I hope you had a good weekend. Second of all, welcome back. So last lesson, we ended it over here. If you're looking at the notes, it's the second page of Skill 39. And we did problem number 1 and 2 on your Skill 39 IP. Yeah, it was just solving stuff, right? Now we're going to do a little more complicated stuff, because as we know it, life is a little more complicated than we hope it to be sometimes, and we need to learn how to solve it. But before we do, we need a little basic skills of Algebra 1 and 2. So let's review what those are. Do you guys remember factoring? Yes, you do. As you know, factoring is one of my favorite things, and I joke about it, how I can factor in my sleep. And my husband's laughing as I'm saying it. He should actually try to, like, question me in my sleep to see whether I can factor. I think I can. So we're going to visit that so that we are ready for the actual complicated problem later. So let's, what kind of factoring method have you learned so far? I'm just going to write it here. You don't have to write it. I'm just going to go over it with you. First of all, the most important thing you have to remember about factoring is that oh, my hands are yucky. I was painting with my daughter. The first step is always going to be factoring out the greatest common factor. So deciding what kind of factoring method you want to use, that always has to be done first. What is greatest common factor? The factor that goes in all of your terms in your polynomial. After you pull out the greatest common factor, you have all list of different things you can do. Let's go over that. If it's a trinomial with the exponents being double, so for example you have an x squared term and x and a constant term, or anything like that, you're going to use ACB chart. Remember that, A, C, and B, you find two numbers and multiply, blah, blah, blah. Or if you have, you can have difference of two squares. Give me an example, something like a squared minus b squared equal to a plus b times a minus b. We looked at some of those examples on last 2 lessons ago, I think. What else have we done? In Algebra 2, we learned sum of 2 cubes. Guys, remember that? A cubed plus b cubed equal to, what is it? A plus b times a squared minus ab plus b squared. Wow, I can't write. Or difference of 2 cubes, a cubed minus b cubed equal to a minus b, a squared plus ab plus b squared, although I don't think you're going to see any of the cube factoring on this example. The most important one for today's lesson will probably be the top 2, which we covered in Algebra 1. There are a few more. We can do grouping, we can do synthetic division, if you know the possible factor using the, what is the theorem name? Wow, I'm blinking, but anyhow. So those are the things we can do to factor. So let's go. There are 6 problems. Let's look at the first left top. First step, what is the greatest common factor of those 2 terms? 1, so move on to the factoring method. What kind of factoring method would you like to use? Notice that you have 4 and sine theta squared. And 1. 1 is a 1 square as well. So do you see it's going to be a square minus square difference of 2 square numbers. So I'm going to use difference of 2 square. Steps of doing that, you need to rewrite it in the roots. So what square gives me 4 sine square theta? Well, let's break it up. 4 is what square? 2 square. And sine square theta is sine theta squared. So your root will be 2 sine theta. What about 1? 1 is 1 square. After you break it down into that, then you can go ahead and use a formula or whatever you call it. It's going to be a square minus b square is a plus b times a minus b. That square minus that square will be that plus 1 times that minus 1. There you go. After you think you're done factoring, just double check it one more time. For each factor, can I factor it further? Meaning, is there any greatest common factor inside of it? Any different factoring method I can use? No. So that's when you stop. Cool? Well, that one you can quickly do it. What I suggest you doing it is actually pause this video. Yeah, actually pause it. I'm watching you. Yeah, pause it. And then redo this problem and come back. Alright guys, did you try it? Well, hopefully you did. So let's go. Mrs. Majors, when I see it, that's a cubic, so I don't think I can use difference of 2 squared. Well, correct. However, you're missing one very important point. What is that? That is, what is always the first step of factoring, guys? Yeah, factor out the greatest common factor. Did you do that here yet? No, I haven't. So let's go. What goes in both those two terms? Cosine of theta. Great. Cosine of theta. Factor it out. Then we're left with sine square theta minus 4 cosine square theta. Right? Then look at inside of the parentheses. Notice all of those are the square numbers. So I can go ahead and do the difference of factor difference of 2 squared. Sine square theta is sine theta quantity square minus 4 cosine square theta is 2 cosine theta square. So using that, it's going to be sine theta plus 2 cosine theta times sine theta minus 2 cosine theta. So just for fun, how many factors do I have here? 3. How? 1, 2, 3. Right? For factors, and that's all the multiply together to come up with it. Notice I can't factor anything further. So that's how you use difference of 2 squared. So that actually the top row is about difference of 2 squared. Now, if you look at the bottom one, you kind of see the pattern. Remember, math is all about recognizing the pattern. What pattern do you recognize here? All of those problems have how many terms? 1, 2, 3, 1, 2, 3, 1, 2, 3. So guess what you're going to do? You're going to factor the trinomial. And it's going to use, what kind of factoring method do you think you will use for this type of problem? That's right, you're going to use the factoring trinomial ACB chart. Why are we using ACB chart? It's a trinomial, and if you look at the exponent of each term, that's a 1 double, 1 double, 2 double, 4. So I can use it. I'm going to do this problem with you in the middle. All right, first step, factor out the greatest common factor. 1, skip it. Next, since your exponent double, I can use ACB chart. So A times C is 4 times negative 3, negative 12. B is 1. Find two numbers, multiply to negative 12, add up to be 1. Ooh, isn't this fun? It's like algebra 1. What are those? 4 and negative 3. Once you have 4 and negative 3, go ahead and rewrite it. All right, here I'm going to have two different groups of people telling me to do two different things. If you want, guys, you can rewrite this as 4x squared plus x minus 3. Instead of tangent theta, you use x. Factor it out, and then put that tangent theta back into where x is, if that looks confusing to you. However, I know some of you this does not confuse you, so I'm just going to go ahead and do it how you will do it. What am I doing? 4 tangent square theta. Instead of tangent theta, you're going to use those two magic numbers to write it as 4 tangent theta minus 3 tangent theta, and then minus 3. Right? Because over here, you would have been doing the same thing like that. Factor 2 at a time. Greatest common factor is 4 tangent theta plus 1. Over here, greatest common factor negative 3 tangent theta plus 1. Tangent theta plus 1 times 4 tangent theta minus 3. I know I'm going a little fast for you, but it's really just the basic, right? Same thing over here if you're using this method. 4x, x plus 1 minus 3x plus 1, x plus 1 times 4x minus 3. And instead of x, using the tangent theta, same answer. Right? Okay, now let me look at this problem right here. Once again, it doubles, so I can use the same method I did on the left problem, except, well, yeah. So first step, greatest common factor is 1. ACB chart, A times C is 1, B is 2. Find two numbers, multiply to 1, add up to be 2. 1 and 1. How easy can that be? All right, now, well, let me do this one first. 1 and 1. So instead of 2 cosine squared theta, I'm going to write it as 1 cosine squared theta plus 1 cosine squared theta, because those are your two magic numbers that you got. So cosine fourth theta plus, 1 cosine squared theta plus 1 cosine squared theta plus 1. Factor 2 at a time. Greatest common factor of the first group is cosine squared theta plus 1. These two greatest common factors 1, cosine squared theta plus 1. I get cosine squared theta plus 1 times I can't write, see, squared theta plus 1 as my complete factors. FYI, you could have done it. However, guys, do you guys remember the trick? The trick is that if the A value is 1, you don't have to go through this step. You can just use those two magic numbers to write it as a factor. So how did you do it? Usually if it was an x, you're going to write it as an x plus 1 times x plus 1. However, this is not just the x. What is your x here? Cosine squared theta. So cosine squared theta plus 1, cosine squared theta plus 1. So you could have used a shortcut if you wanted to. Okay? Alright, so that's the factoring problem. Now, let's actually do it. Solve the equation below without the aid of the graphing calculator. Find the solution on an interval, blah, 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 blah. Alright, guys, as soon as you see this, you know this has to be in radian, right? Because it has to be 2 pi, meaning we're not doing degree, we are doing it in radian. So your answer is going to have a pi in it, especially you're not using a calculator. Alright, so what's the game plan here? Game plan is the following. When you're doing the complicated equation, you always want to set it equal to 0. Move all the terms to the one side of the equal sign. And then factor if you can. And after you're done factoring, you're going to set each factor equal to 0 and solve. I mean, that always has been a theme that we've been doing since Algebra 1 World. However, sometimes that doesn't work, and I'll show you which problem it's not going to look like that, and then we can go from there. So let's go through the step. There is my equation. Number 1, set it equal to 0. Move everything to the left side of the equal sign. So 2 sine squared theta minus sine theta minus 1 is equal to 0. Let's factor. Greatest common factor 1. Determine which factoring method you want to use. Notice a trinomial with the exponents 2, 1, it doubles. So I'll probably want to use the ACB chart, like the one we did on the previous page. A times C is -2, B is -1. Find two numbers, multiply to -2, add up to be -1. What? -2 and 1. Alright, now go back to the original equation over here and then use those two magic numbers to rewrite it. So 2 sine squared theta, instead of this middle term, you're going to use -2 sine theta plus 1 sine theta and then -1 equal to 0. Factor 2 at a time. Greatest common factor of that group is 2 sine theta, left with sine theta minus 1. These two GCF is 1. Sine theta minus 1 equal to 0. Okay, let's keep factoring. Sine theta minus 1 times 2 sine theta plus 1 is equal to 0. Can I factor any further? No. Alright, so we're done factoring. Now what do you do after? You're going to set each factor equal to 0 and solve it. So sine theta minus 1 is equal to 0. 2 sine theta plus 1 is equal to 0, and each will yield different answer. Well, your solution for this problem will be everything, but each factor is going to give you different answers. So I think this one, I don't know how many solutions this one has, but more than one for sure. So let's go. Add 1 to both sides. Sine theta is equal to 1. Since you're not giving calculator, that means it's on the unit circle. Wait, what is happening here? Did I do something wrong? Give me 1 second. Oh, am I doing? All right, sorry, brain freeze. Sine theta is equal to 1. What does that mean? On the unit circle, remember, sine goes with the which coordinate? The y coordinate. So, which angle in radian gives you y value of 1? Where's the y value of 1? Right here. What is that angle in radian? Not 90 degrees. It's going to be pi over 2. So, that is one of the solutions. Okay? Now this one, subtract 1, 2 sine theta is equal to negative 1 divided by 2. Sine theta is equal to negative half. So on your unit circle, which angle in radian gives you y value of negative half? Right here, which one is that? Y value, so it's going to be the denominator of 6. So 7/6 the pi and 11/6 the pi. If this is the part that you're just struggling, you probably need to revisit skill, whenever that was, the solving trig equation. Which one was that? Give me 1 second. Ooh, skill 35. Review skill 35. That part was what you're like, what just happened? Okay, so you have 3 solutions. 1, 2, 3. If I'm not going to do the bottom problem, guys, but I highly encourage you doing that. So I'm just going to quickly show you. This is what you're going to get when you're setting equal to 0 and then factor it. Once you set each factor equal to 0, notice that over here tangent theta is 1. That's on your table for skill 34, which angle gives you tangent value of 1. It was pi over 4 or 5 pi over 4. However, notice over here when you set it equal to 0, you get tangent of theta equal to negative 2, which that is not the value that we learned in the unit circle. So what are you going to do? Actually, for that part, you need to use the calculator. So I know direction doesn't say it, but you really need to. So you're going to do the inverse of tangent, then plug that in your calculator. Make sure your calculator is in radian mode. Blah, 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 blah. You get that. Since tangent is negative, that means 2 are opposite signs. So second quadrant, fourth quadrant. Remember what we did on that? Blah, 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 blah. So you get those 2 solutions here. Notice this problem has 4 solutions. 4. Yeah, so very important. If I were you, I'll probably pause this video and kind of look through it one more time and actually plug it in your calculator to make sense out of it. Okay? Promise me. Yes, Mrs. Major. Oh, thank you. All right, so that is that. We are not going to do this problem because we need a different trig identity that we haven't learned that before. Just don't have time for that. Now, if you look at the back page, I know we don't have enough time to practice things. I love this problem. I really do. I'm actually going to make a separate video about this problem because my heart is just so into it. So, I'm actually going to finish skill 39 video for here, but make a separate video explaining you this problem. So if you're like me, oh, I love the challenge. I just have so much time sitting on my couch. I am sick of watching Netflix. I love to watch your video. Feel free to watch it. I'm not going to require you to do it, but it is very fun problem. So tune in there. So that concludes the lesson. What will be your IP? You already did number 1 and 2 IP. You can do number 3. Can't really do number 4. Wow. Number 3 only? That doesn't make sense. Number 3, and I need to make one more problem. See? I will make a new problem and then I will upload those on Haiku. So tune in there. Alright guys, good luck doing your IP. Bye bye.